This week on Space News Underground, we bring you up to date on DARPA's Phoenix program and the cluster of space debris forming around Earth. You may not be aware that Earth itself has rings just like Saturn and the other gas giants. Well, we may not have rings exactly like theirs. The majority of these artifacts are remnants of retired satellites, also known as space debris. Some of this space debris is found in a path of flight known as geosynchronous orbit. These inactive satellites and other artifacts have become a growing problem as humans become more involved with spaceflight. This space debris is potentially dangerous to current and future space missions and projects. Objects in low Earth orbit can travel up to 17,000 miles per hour. Traveling at these speeds, something as small as a fleck of paint has the capability of damaging a heat shield, cutting through an astronaut's suit, or even damaging the vulnerable parts of the International Space Station. As we keep shooting satellites and telescopes into orbit, our planet's orbital region becomes more and more cluttered. If we want to keep exploring the cosmos, then something must be done about space debris. Luckily, defense company DARPA has proposed a temporary solution. Recently, they announced the Phoenix program. The Phoenix program is a robotic aerospace vehicle designed to disassemble and reuse parts from retired or inoperable satellites. The vehicle will then reassemble the pieces salvaged to create a nanosatellite, or a satellite. The satellite would then be encased in a pod and sent to geosynchronous orbit by hitching a ride on a commercial spacecraft. Once in geo orbit, the satellite would be intercepted by the aerospace vehicle, also called the tender. The tender then places the satellite in its tool belt and links up with a retired satellite. The robotic arms of the tender would then construct the satellite using the retired satellite antenna. The tender then places the final product in geosynchronous orbit and sends it on its way. Several of these antennas can create a communication farm. The Phoenix program will surely be beneficial for the space industry, but the real impact is the removal of space debris and safer orbital operations.
The biggest issue with these space debris is they are taking up valuable space in the very unique geosynchronous orbit. This orbit matches Earth's rotation period, meaning that any satellite in this orbit will remain locked in the same position day after day in relation to Earth. So every day at any second, a satellite in the geosynchronous orbit can be found in the same location it was at the same second the previous days. A benefit of this orbit is a satellite can gain coverage up to a third of the Earth's surface. Additionally, GEO satellites are able to send a steady stream of data and even follow storms as they happen. Also, these satellites only require one tracking station. However, due to the high altitude of these satellites, it takes about 1/4 of a second for the signal to reach and return to the satellite. This creates a minimal but significant signal delay. This delay impacts the difficulty of phone calls and can affect common network protocol performance. This delay has little effect on non-interactive programs such as TV broadcasts. Lastly, due to the flight paths of these satellites, they cannot cover polar regions. For many, the advantages have far outweighed the stated disadvantages, and GEO satellites have revolutionized global weather forecasting, communications, television broadcasting, and even multiple defense and intelligence applications. That's it for the Phoenix program.
So make sure you keep yourself up to date on its progress. See you next
time
week on Space News Underground.